Hey guys, Professor here. Today we're going to be having a look at flight controllers, radios, and almost ready to flies. Basically, I get asked a lot. I bought one of the AFR's racing drones and I can't figure out how to hook it to my radio. Fair enough question. Everybody starts somewhere, so let's get started here. We have what we call a PPM receiver, or a pulse position modulation receiver. We have a standard PWM, or pulse width modulation receiver, which is these types here. And these are generally what you see in most RC beginner setups. This is a satellite receiver, which we'll get into how to hook that up in just a bit. But first, let's look at how the relationship is between our receivers and our flight controllers. So basically what a flight controller does is it takes the signals from a receiver. It receives the signals in pulse form from your different types of receivers, either your serial, your pulse width modulation, your pulse position modulation, and it takes those signals and sends them to the flight controller. Your flight controller then interprets those signals and combines them with the flight data coming off of your sensors, which are your gyros, which tell the unit which end is up. Now on a flight controller, we have an input, which is here or here, and then we have an output, which goes to our motors, which are here and here. So for the CC3D, this is the Atom, which is just a smaller version of the CC3D, but if you see, it has the same plug right here. Now this setup here is what we call a pulse width modulation, which is your generic PWM input. And the easiest way to hook one of these up is you plug it in. It only goes in one way. Make sure you don't force it the wrong way. And then you look at your wires. Your first wire has 3 wires on it. It has a black, red, and a signal. So we're going to take that, and that's our channel 1. And we're going to hook that up to channel 1, which is our throttle channel. Now, on this particular lemon receiver, facing up is signal. On different receivers, there are different signals, usually inbound though, on most receivers. But if you look, you can usually see, I don't know if you'll be able to see it or not, but it says negative, positive, and signal. So that's signal, positive, and negative. Negative's usually to your right or outside, headed away from the unit. Your signal's usually inbound. And that goes for all of them. You just have to pay a little bit more attention. These curve in, so that's still inbound. But that being said, now on the CC3D, we're going to grab our second wire. We're going to hook it up, making sure the signal's up. That's channel 2. We're going to grab our third, or channel 3, and we're just going to keep hooking them up like this. Now you can actually change these things in the Libre Pilot or Open Pilot, and these channels can be swapped around to do different things if you want. You're only using 6 channels, but I go ahead and hook the last one up, or 5 channels. Go ahead and hook the 6th one up just to get it out of the way. Now when you're looking at it, you'll see the only one that has 3 wires is your first channel, which is your throttle channel. And then we go to number 2, and then number 3. Oh look, but see, now this is a common mistake. The wire gets flipped around. It doesn't hurt anything, but all of a sudden one of your channels isn't working when you're going to program it in the Libre Pilot. So what you want to make sure is you want to make sure that all your wires are facing across the same, and so what you want to make sure is you want to make sure that all your signal wires are across the top, or in this case they would all be inbound and not swapped around. It's not going to hurt anything, but your unit's not going to work. you're going to have dropped whatever channel is facing the wrong direction. So that's basically how we hook up a PWM, or pulse width modulation, to a CC3D. Now, the rest of the unit is going to already be hooked up to the motors because you bought an ARF. But now all you do is your receiver should already be bound with your transmitter. Turn your transmitter on, run through the setup wizard, and you're done. Now, for a little bit more advanced take on these things, this is also, if you look, they'll use jumper wires, and your PPM on your input side still works the same way. Your ground is on the outside, your signal's on the inside, your positive. You hook your PPM up to here, and then when you program the board, you're going to tell it this is a PPM unit, not a PWM unit or a satellite. Now, satellites can be hooked up the same way. There's a little bit of soldering required with these, but basically, like if you want to hook a satellite to a CC3D, we use the primary port or main port. We just plug that into there, and then you're going to have to solder this one wire, and it's hard to see on this board. Let me grab this board. Now, this is what we call a 180 flip board because it's made for the skimmers, but same type of setup. So we would plug this into our main port or our flex port. You can assign either one. I like to use the flex port. And then what I do is I run the wire under the board, come back up, and you'll see this 3.3 volt positive connection right here. Now be careful when you're soldering it. You know, you don't want to jump it over to the SBL, which is your boot loader, and that'll automatically put your unit into boot load at all times, and you don't want that. But that's how this is how we're running a lot of them now. This is a Spectrum satellite receiver. Actually, this is the Lemon, which is the knockoff of the Spectrum. We find it works pretty well. The Spectrum gives us a little bit more range, but the Lemon, bang for the buck, is obviously the better choice. Now, so we've taken a look at how to hook up a PWM, we've taken a look at how to hook up a PPM, and we've taken a look at how to hook up a satellite receiver to our different and various boards. And all of these are interchangeable. They just have a different spot. You'll have to check with the manufacturer. All boards are a little bit different. Now, there's also the Futaba S bus, which we don't have here because we don't carry Futaba products. But just a little bit of background. If you're looking, this is our pulse width modulation. So basically, every 20 milliseconds, this unit is sending out a pulse, one per channel, and that pulse is the command signal for your flight controller. And so when it sends that pulse out, it gives the position that the servo should be in, or in this case, where the flight controller should be in its relative stick command. Now, pulse position modulation, or PPM, now that's a little faster protocol, but what it does is it stacks all your pulse width modulations. It stacks them one on top of the other on top of the other, and it does this all. It can do up to 8 channels in 20 milliseconds. So that's a much faster protocol. It's a single wire, but still my favorite is the satellite, which is a modified serial. It sends its data down one line, receives its power, it auto binds. I mean, that's a clean setup right there when you're done with it, and it's easy to mount. It's tiny compared to the rest of them. But satellites can also be used in conjunction with PWM receivers. And basically what that does is that extends your range. Now you've got 2 receivers, a primary receiver and a backup receiver, just in case things go awry. This is usually used in some of the bigger, larger RC models that cost quite a bit more. They extend the cord out. They move the satellite, put it to one end of the aircraft, and then they put the receiver on the other end of the aircraft. That way they get the best, and then they mount it in various positions to get the best signal, so that way they don't lose these, you know, $5,000 and $10,000 units. Well, I hope that explains a little bit more about how to hook up an ARF, and like I said, there's all kinds of different ways that you can mount these things once you get them in. One of my favorites is I slide them in the side here, or you can put them under the bottom plate here and stick these through here, but then your wires are sticking out. But like I said, my favorite is the satellite. I double-sided sticky tape it right there. It goes straight into there. You're done. If you like what you see or you have any other questions, feel free to like or comment below. And thanks again to the folks over at Dragonfly Racing Drones for helping us out and giving us all this stuff so that we can show you a little bit more on how things work. Thanks for watching. And if you have a question, ask the professor. And if I don't know the answer, I'll probably make one up. It'll sound good anyway.